Just we will not wait for the rest and just read episodes so for Shazar and then chat.
Mm-hmm.
You have something to read this?
Yeah, I have.
Yeah, please. Sure.
Copies?
Sure. So you just take a seat and start reading. Do you have something to read with, please? Take.
editing, thank you much. It's really helpful. There is a double, triple goal. You're helping on one hand, you're borrowing ideas on the other hand. The third thing, if something is not clear or you do not like something or just curious, just ask on the margins. Like, give an example of whatever. Just asking what are the things, what can I do with it? Just try to discuss if you have some curiosity. That's it. Just questions. have the code for the luminescence. Also, please send email to everyone and wait who will help you first. You will Fatima or
Okay. Oh. Yeah.
It's almost the same input data, so there's a very little change.
Okay. Nope. Oh, not a problem.
Is this hydrogenated or hydrogen precipitated? This is silicon, crystalline silicon, right? So it is hydrogenated or hydrogen precipitated?
What's the difference?
I don't know.
In my opinion, there is no difference.
Do we need to have a
Hydrogen
project
is like
that we have to work on together on Friday?
organic
Or present?
Yes, one of you should present.
Oh,
But better if David.
Is this
Okay.
And you are invited to attend anyway.
okay, because we're talking about it on Friday.
If he's if David is hesitant,
He is.
you
That's why I thought
you either twist his arms and make him present, or you present instead of him.
Okay, because yeah, he told me that we're both presenting, but I'm gonna do most of the talking since it's my work. But I thought I don't know whether it was his project or my project.
In neither one is perfect, but in account of academic accomplishments, you have much more than him. He needs it more.
He needs more. Okay.
And
Because we were gonna get together and work on it again. Well,
Yes.
have it completed tomorrow. But I was just wondering how do I go about this. But that's good. Thank you.
and it will be no challenge. It will be too easy for you. You are a good public speaker.
Yeah.
You just contribute data. It will be good practice for him to try.
Well,
I'm
he
going-
says he wants to join the group too. So good practice.
So, did you share with him on dimension or what for another model?
That's what we're gonna talk tomorrow because you remember how you did the cesium at that ridge surface for me? I had the lead at that, so the other surface. And I guess we could just compare those two, right?
Yes, it will be really interesting.
Yeah, that's what we're gonna talk about tomorrow. So I can show him that information, and I'll give him all the information, and he can work on his PowerPoint and ask me questions, right?
Yes.
Okay. Yeah, because for that, you know how if they rotate, they have to write a report.
He already submitted the report and
Yeah. He put my name on it because he said if this doesn't work out well, you're going down with me. But I was like, okay.
he wants to make you responsible.
He wants to make me responsible. Yes, if it doesn't go well, that's fine. So I was just wondering what the project for Friday was. If I had to talk or if he talks and I just show up.
I already figured out the sequence, so he will present it like number 4. And total will be 11 presenters.
And do I still have that one thing I have to present on? Do I still have that one thing that I need to present?
Well,
Because I thought my thing was David's thing.
that's right.
Okay, so I just have to
And
show
it's-
him
it's
my stuff.
undergraduate course, you cannot get grade for it.
Yeah. Okay.
really nice sound.
Oh, good question.
Yeah, you already answered it, but I was curious about it. So, anyone wants to chat to something about Daniel's brain? So, it's a good writing, but you know, like in ancient Greece, professional wrestlers were covering their skin with oil, so you cannot catch. So you formulated it in such way that you cannot be, we cannot catch you in anything.
Yeah.
But you may want to expose something like what is the, you do not show results and you do not tell about them, but you can just make some vague hypothetical, but something that looks like a result. Right now it reads great, but it is very general.
Yeah.
And you already have enough results. Just tell which one relax quicker, which
Say
one.
something.
Yeah, which one, which of this. You even do not mention which, what are the different morphologies, right?
Okay. Yeah. I don't.
But probably it will be not a big problem to.
Easy fix.
Yeah, just to
Okay.
more specifically and tell which of them. Any very general differences, where it is quicker, where it is slower, where is larger number of surface states.
Okay.
Anything else that?
I guess somewhere you mentioned you calculated dependence of electronic structure on composition, quantum confinement, and also surface morphology. So did you actually do it?
Yeah, but
I can
Did you
tra-
modify the
I can translate. Daniel tried two morphologies,
Okay.
and he tells I'm investigating the dependence. So it's not. It sounds like he studied 2,000 morphologies, but in fact there were just two.
Okay. How about composition? Did you modify its composition?
composition stayed the same, other than just the interaction at the surface was different.
See, Yuan is criticizing.
Huh?
But Yuan is criticizing you.
Yeah.
If I want to advocate Daniel, I can tell when he has lead or cesium surface exposed, total number of lead and cesium surfaces is different, and concentration of lead and cesium changes. Like if you have only one cesium surface, it will be only there will be no lead at all. If you have two cesium surfaces and one lead surface between them, concentration of cesium will be twice as bigger than lead. And which is okay, but if you have sandwich of one cesium in between and two leads on the opposite, the amount of lead will be twice as bigger than cesium, right? If one makes very thin films and exposes different surfaces, it will be different concentration. and to some sense, one can tell that it is composition.
If this is the case, then you cannot compare dynamics between different systems, right? Because you have different models.
It doesn't mean that you cannot. You can, but you need to tell that those are different systems. The comparison may depends on several. If you're telling that you're changing several factors simultaneously, then your dependency is also not linear. There are several factors, and nothing wrong with it. But you need to be careful and mention it.
And how about the quantum confinement? Did you change the size of the parse guide?
Quantum confinement. No, we just looked at it at a 2D model. So
No. 2D model, that's okay. But did you try models with like 3, 5, 7, 9 layers thickness? Did you change?
No, thickness did not change. Well, I guess.
Did you try it?
Did I try it? No.
Do you plan to try it before the conference? Would it be, do you think it is easy enough to check?
I could try. Yeah. I mean, it shouldn't be.
Well, do not promise too much, but if it is possible, you can mention it in the abstract. To compute non-adiabatic dynamics with different number of atoms, it's almost too late. But if you are looking for just ground state, then it is like, and if there are computational resources, it's maybe like 2 days per system, so you can check a lot of stuff. And it could be interesting.
Yeah, thank you.
Yeah. Thank you, Evan, for. Fatima, do you have any?
I'm not clear. It says that optoelectronic properties here.
Uh-huh.
So which optoelectronic properties and which optoelectronic properties are studied here?
Which ones are studied here? Well, hopefully I'll have a little luminescence yield.
You already have absorption.
Yeah, absorption is one of them. I just didn't want to say that because I guess that's one of the first.
Oh, you want to sound smart and fancy, and then therefore instead of absorption, you've taught optoelectronic properties.
Yeah. Yeah.
Okay. We disclosed you.
So you studied optoelectronic properties for in case of this composition, quantum confinement, and surface morphology.
Mm-hmm. So the optoelectronic properties were based off the cesium-led bromide perovskite, and with those we took a closer look at composition. So the composition was one, how Dimitri was saying, one was a cesium-rich surface, while the other one was a lead-rich surface. And quantum confinements, I guess, he gave me a good narrow look into that. Well, somewhere to look into that. Then surface morphology. Does it, I guess, in this sense, doesn't that also mean the same thing as composition? Surface morphology and composition. I guess in what I'm looking in.
Those are different words. They overlap, but they have different things. Like you can have the same like if you desorb your ligands from the surface, but they're still in the simulation cell. It will be the same composition but different surface morphology.
Okay.
Or if they adsorb, if you turn your molecule by 180 degrees upside down, it will be the same composition but different surface morphology. You probably do not want
Even
to
if it's
do
symmetrical?
No, you do not want to do it because right now you already stick the chemically active site to the surface.
Mm-hmm.
I'm just telling hypothetically, just semantically for verbal construction. If you flip it, it will be silly from chemical point of view, but verbally it will be same composition but different morphology. Did you print anything?
No, I did not. I had to rewrite a whole business report by midnight tonight.
Do you have any draft of an abstract?
I have my last year's abstract, I guess, which is probably not great, but still, yeah, we're still doing the 1-day thing at that point, so that would not really be very applicable.
Can you maybe quickly do something like print in 5 minutes? Maybe first.
I could try to bullshit something together real quick.
Yeah, because time is flying by.
When is the abstract due? End of December?
Yeah.
Or like 15th or something?
End of December.
Okay.
But who knows? Each of us may suddenly develop plans to go to resort and or just dedicate time for something.
I have to go give my final now.
Yep.
Thank you for your comments. That helps.
Yeah, please come back. Maybe let's read the one by Aaron, then we'll continue discussing. I'm sure you're enjoying this.
So for Sanibel, I should probably focus on the research that I already have completed, right? And then just like probably, mention in person when people are talking to me what we're going to be doing going forward? Or do you think?
Prepare for the sound?
I guess how do you think I should?
Well, the plan, I don't know about your plans, but my plan was to have your paper completed and submitted before now.
Yeah.
But since it is not submitted, everything which is not submitted is considered as new. On this side, yes. But it is personally, if I submit things myself, it is so boring to talk about what is already done.
Yeah.
It's better to maybe promise something that you cannot complete, but it will drive yourself forward. So tell more about new project or improvements in the project, and maybe make connection with 40% of old project there. But again, it's creative. As soon as you complete it and share,
Yeah.
you'll read and give you feedback. You have so nice and developed capstone proposal and almost ready paper, so that there are no doubts in your skills as a writer. Prepare for the sound. about other things? You don't listen to us, just
I think I'm almost done here.
Oh, yeah.
At least with like a
do you have an access to printer nearby to print the book so that
I mean, like not very close, but I know where I can go.
like in 5 minutes?
Yeah.
It would be better. We can try sending it to everyone and we look at it on laptops, but it's not that much. Let's keep chatting if you don't mind. So anything about the abstract by Aaron? I do have a couple of scattered comments, which I don't know if they're helpful or not. So if since it is a conference for theorists, they either know or expected to know some basics of Polaroids and Polaroid Hamiltonian, which is like one of the standard advanced topics. And same like Daniel 20 minutes ago was telling optoelectronic properties instead of absorption spectrum. To look and sound fancy. One can also tell that like the concept of Polaroid is not known, and Hamiltonian is not new. Concept is not new, and Hamiltonian is not new. But one can tell that we are trying to find values of couple of constants for standard Polaroid Hamiltonian from our initial calculations. Basically, it is what you did for Ben when you gave him energy offset, vertical and horizontal offset for reorganization energies.
What was that? We call it like it's like alpha coupling constant.
Yeah.
But that shows up.
Yep.
Whatever.
Well, one can call it different ways. Here is probably not the best one. One can write it in several ways. We are not discussing Hamiltonian. There is no place to write it down in the abstract. But for the language, for interacting with the people who will be reading on the conference, you can tell that one attempts to find values of constants for standard power and Hamiltonian, which will be right what you're already doing. Figures are already always good, so we would put your recent figure with arrows, telling like which atoms experience best largest shift upon creation of a polar. This would address like broader audience and everyone that would like to see it at that point of abstract. Couple of papers to yourself or to whatever popular publications went over in the last weeks or month. There is no issue. And there is a interesting work that Ben is doing based on your parameters, and we may chat privately what is the best arrangement to offer him to travel, but then he needs to talk to his advisor, and it's a complicated thing. Encourage him to submit abstract and you present his work, or you just put like your poster will be like 3 columns and 1 column will be based on his results if you're interested in, because it could be good part of your awareness. Why not? So if you do it, it will be role of quantized nuclear motion, like from quantum factors for overriding optical properties. And you're mentioning sensors, but probably there are some other applications. Just generally, who needs an infrared emission? You want to have ideas? Were there infrared applications of lanthanide emitters? Or everyone try to do into visible only?
Yes, we have samarium and dysprosium, I guess, for near infrared emission.
And industrially, what are industrial applications for infrared emission?
No idea.
Well, it's not critical if you do not mention. It's fine, but it's a seed of a thought. If you mention something cool, it will be later useful. Also, maybe to attract more experimental collaborators or just broader audience. I have some ideas, but they can be not applicable to toxic and non-stable perovskite. So bioimaging means if you feel bad, you just drink colloid of lead-containing perovskite. Therapy against for medical applications, but with lead, it's not good. And then information processing. There is a frequency near infrared that is used for fiber optics telecommunications, and any absorber or emitter in the infrared range is considered as industrial devices for information transmission. And who knows, maybe everything else we do will be forgotten in several years, and then people will say, oh, Aaron Florida, he was a pioneer of finding the main emitter for all telecommunications of 22nd century. Even do you have any?
My question is, so basically the Polaroid emission is in the IR region, right?
Mm-hmm.
So I guess, is there any other origins for this IR emission? How can you make sure it is only due to the Polaroid?
I guess I don't know where else IR. I don't know. I don't have a good answer off the top of my head.
So if
Usually thermalization is faster than light emission, so they give off heat quicker than IR.
so if there is an inverse occupation at the edge of either valence or conduction band, to some extent it will lead to the same nuclear reorganization as if one would inject charge for creation of polaron. So the question is like, is there any other mechanism of infrared emission other than polaron emission? Would it be a theorem, for the theorem? Any infrared emission is a polaron emission. It's, well, right now it is just hypothesis, but and definitely here in this system the nuclear reorganization plays a role. So it's one of the situations where our approximation of rigid system is in doubt. So what probably will be done in your work to assume that reorganization has already completed and there are still electronic transitions for nuclei near equilibrium, but it will be equilibrium for Polaronic state, not the ground state.
I guess in experiment they don't see IR absorption unless there's a polaron. I guess at certain temperatures they don't see IR emission. And then when they get to temperatures where there are polarons, they see absorption from those states. I guess if you consider absorption and emission inverse.
Fatima, do you have any suggestions for Aaron's work?
I have a question about this non-radiative recombination. Kappa NR, is this the same as kappa non-radiative? Radiative one. The symbol just it's
I guess I don't have a version in front of me.
so is this one is same as this?
Oh yeah, I should. Yeah, that's supposed to be the same.
Okay.
I might have just copied and pasted that, so I have to change that.
So, done? So, about the abstract by Fatima. Why hole? Well, you need to explain it formally. Probably everyone here in audience understands how hard your calculation is, and the reason is that you just systematically, because to do everything at once is too hard, you do first electrons, then holes. It's like chapter 1, chapter 2. But it will be a little strange if you explain it in the abstract or when presenting. So one can make up an argument telling like holes are more important. Oh, that's great. Thank you. Some applications where holes are more important than electrons. For example, we can ask London. In which applications holes are more important than electrons? And I think Yuan also has the answer to this question.
I mean, like if you're looking at the interface between like your perovskite and your hole transport material, then obviously you're trying to look at holes.
Yes, so
The first thing that comes to mind.
So it would be a good thing to put here, right? So if you have, yeah, that's a great idea. Yeah, thank you. If you Fatima is focusing on hole transfer in silicon materials with enabled momentum, and the original reason for doing it is likely that just it's too hard to do everything at once. Electrons are done. Now you focus on the holes. But for general audience, you need to tell what is special about holes. And one of the possibilities is that if you develop a photovoltaic cell, it will have the charges needs to be put to like anode and cathode. You need to separate it, treat electrons and holes on different terminals. And if you take only the part of solar cell with holes, or part of the light emitting diode where holes are moving, they're important. So one can make this connection. Good. Another idea from the paper by Yuan. Molecular Physics 2015 with there were two, with Sergei Terezak and David Mitchell. So when silicon interfaces gold electrode, the band alignment, the density of states for gold is so much, although it is metal, sometimes it has no gap, but in the occupied, it is so much denser. And the first thing that transfers upon photoexcitation of silicon, first there is a hole transfer to metal. It's also possibly an idea where one needs holes more than electrons. Do you plan to? But you're hesitant to promise it in the abstract.
Oh, I can edit this one since.
Yeah, just mention that there are some steps in this direction, because it is goal anyway, and for other projects that we will do sooner, it will be all projects will include photoluminescence on carbon nanotubes and on iridium complexes. Well, there are some things about language and make it more specifically tunable a little compared to what. It's very pity that no one of the undergraduate students from physical chemistry selected the following topic, but it would be really great to try project your nanowires onto one-dimensional potential, same as like London did in the past, same as Daniel Ramirez did for his friend recently, and then try to reproduce dispersion, momentum dispersion. I don't know. On its own, it will be insufficient for publishable paper, but one day you may do it for curiosity, or wait next year until there will be more undergraduate students. So if you do one-dimensional potential, one of the ways, one can do it probably several ways. Instead of diagonalizing Hamiltonian, diagonalize just momentum, and then plug eigen states of momentum operator into like find expectation values of energy, and then plot them one versus another, which should reproduce the dispersion curve.
Okay, so what I understand, this is suggestion for.
Yeah, it's a suggestion. It's suggestion for the future for someone else. It's not for your abstract right now. It's just to launch thinking. But were there any more? Well, this was my fantasy. But other more constructive suggestions to Fatima's work? So everyone is happy. Convinced. Okay. So is it right that this project was this project started because one needs to deposit the isonium on the carbon materials on the nanotubes, but it is too challenging, and one needs to go slowly but surely. Yeah. So the immediate question, even before we discuss science, what is the motivation? Because we are clear with our own motivation inside the group that we want to deposit the isonium salts on the carbon nanotubes. But it will be too big of a logical breach if you start paper. We want to deposit the isonium on nanotubes, therefore we study silicon. So there should be some formal motivation why the isonium on silicon is reasonable. What are the industrial applications or just overall intellectual benefit?
I guess experimentally they have used these salts to modify silicon surface. So they have some experimental evidence, but I guess the computational description is limited.
Okay. One can probably mention it right away, the first line of the abstract. And what does it do to a silicon surface?
Just to put carbon rings onto the surface. You mean the specific applications?
Yeah. What does it do to the surface? It may increase stability, because when it is covered by hydrogen, it will be like if you pour water, it will immediately change electronic properties. But if you cover it with like nitrogen or carbon chemical bonded to surface, it will be stable in that atmosphere.
Okay.
So it's like stability to meet not aggressive but to like ambient conditions.
Mm-hmm.
And Fatima may have ideas. Why covering silicon?
Oh. With hydrogen?
Silicon, like this red silicon with organic layers is important for any optoelectronic devices. Compared to in all models that we first try to do, silicon is you cannot leave it uncompensated. We put hydrogen, but experimentally hydrogen is not stable. It will be easily removed and replaced with something, and then hydrogen itself chemically it opens the gap.
Also band gap modification maybe.
Huh?
Band gap modification.
Band gap modification, or yes, maybe removing trap states. So it could be industrial applications. Also, I haven't checked it, but if I would imagine silicon content not covered by this phenyl rings, probably it is what Eric Hobby is doing.
Okay.
Because if one needs, so our closest bridge to Dr. Hobby is Aaron. He's a representative of theory world in the Dr. Hobby lab, right?
Yeah, I was talking with Todd, the guy who does the plasma synthesis.
Mhm,
I think he said Eric was trying to push him to do doping with phosphorus and silicon, but I guess like the intermediates are very toxic, so they're kind of waiting on that until they can improve their setup. Because I guess it's like even if like one of the molecules gets out by some accident, it can like kill on site if you breathe it in.
Mm-hmm.
So, but he didn't mention anything about substituting those rings onto.
But they're doing colloidal. Like you're doing colloidal perovskites, but they were doing and they are doing colloidal silicon.
Yeah, they're still. Yeah, I think they just wrapped up something they're working on. They're trying to find a new direction.
But what is the surfactant? What are the ligands covering silicon?
Normally, or lately, they've been using octyl. It's just an 8-chain
Okay,
ligand,
but it is silicon to carbon.
silicon carbon.
Silicon to carbon, same thing. So stability in colloidal in liquid phase, and
I was just gonna say something with that too. It's like those benzene rings. They're probably absorbing the IR better, so you could probably get energy transfer
okay.
from those two.
So it, although it was not an original idea, it can be really helpful for this colloidal silicon nanostats. Oh, a little of verbal complaint. High temperatures. Well, inside between us, we can understand it really quickly, but for a person who will just read it for the first time, high in respect to what? Just reference point. Like higher than room temperature or higher than melting temperature. Or maybe it's a temperature, high temperature when this carbon materials start to burn. I'm just exaggerating. Well, figures could be useful. Maybe if it is too much to show details, even some hand-drawn structures. Is it right that the reaction goes only here and the attachment of this reactive species to silicon takes too long and you didn't pursue it?
Right.
So it's possible, but not worth of spending resources.
Yeah, because we need to, I guess, try multiple trajectories with different orientation.
Or squeeze it and have
Yeah.
a higher density.
Mhm.
Okay. So for this reaction, when nitrogen goes away and hydrogen attaches to bromine, just for curiosity, would one get any benefits if extracting potential and trying it as quantum? Same as for rocket fuel. I'm not sure. I'm just sharing thought.
I guess I try to plot the total energy
Huh?
as a function of time,
Okay.
but I guess it's just random fluctuations. Guess if we want to extract the potential energy surface, we need to do the
Smearing over nearest time steps.
right, and also just to remove some, non-participating species, something like that.
Well, since there are a lot of hydrogens, and they oscillate with like silicon to carbon and silicon to hydrogen and carbon to hydrogen frequencies are known with a period of like 10 or whatever 20 femtoseconds. So any quick fluctuations from total energy can be removed. Any other so hydrogen motion frequency is about 3 times quicker than anything else. And they are regular if one makes a smoothing step short enough, it will not affect changes related to heavy atom motion.
Mhm.
So
Okay.
it seems doable.
Mhm.
So only reactive hydrogen that transfers will be taken into account, and all hydrogen oscillations can be. I can imagine procedures that will take away these fluctuations.
Mhm.
But we may discuss and sit together and check if it will get any benefits.
Mhm.
It's possible, but who knows if it is needed for this project. Any suggestions for any other critical comments on Yulan's work?
I have a question. There is a word sampling. Question. There is a word sampling. Sampling something.
Or which line?
I don't understand. Fifth
Fifth.
line from
1, 2,
bottom.
3, 4, 5.
Fifth from bottom,
1, 2, 3, 4, 5.
very end.
Spectral line sampling over computation. Okay, yes. I agree with this word, and I'm ready to protect it if if needed. But maybe you will also want to protect it.
What's wrong with this word?
Yeah. What's wrong with
Like
this word?
sampling over area. Just I don't understand.
Did you read the paper by John Fogel
Which
about computing photoluminescence along molecular dynamics trajectory?
Not the physical chemistry later.
Huh?
Physical.
Chemistry C, yes.
Part of it.
So if you have temperature equal 0 and equilibrium, then your spectrum is summation of oscillator strengths times delta right? You agree? But if temperature is much bigger than 0, then there is a trajectory of all ions, and then the spectrum will depend not only on frequency but also on time. At each point of time it will be different. So the oscillator strengths will depend on interatomic positions, which depend on time, and the resonance condition will depend on energy of source orbital, which will depend on positions of atoms, which depend on time, and final state, which will also depend on atomic positions and depend on time. So if you even if there is only transition from Homo Luma, at each point of time it will be different energy and different intensity. And if you want to And if you need the spectrum that will be observed in experiment, you need to add together spectra computed at different steps of time. There is also ergodic hypothesis that average over ensemble is equal to average over trajectory, and one can perform summation together of spectra at different points of time, but assumes that it was not one model, not a single molecule along a long time trajectory, but just many replicas in a microscopic ensemble, like many molecules, each of which is in different phase and slightly different transition energy and slightly different oscillator strengths. So sampling means scan through of the different steps of trajectory. Even did I advocated it in the right way.
Mhm.
Satisfied?
So this project is about calculation of relaxation rate when when this diazonium salt is added to the surface of the silicon slab,
Yes.
right? Study the electron dynamics relaxation rates.
Uh-huh. More question, comments, suggestions to Yvonne's work?
What do you mean by handiness?
What's it?
Handy.
Yeah, I was not sure about that either.
Which line?
Very first one, very end.
last word. Just that it's useful.
Oh, okay. Here.
At first, I didn't know if you were talking about like chirality.
Yeah, that's what I read it as right away, is handedness. I was like, oh, wait a minute, that's not right.
It's just this chemical is very easy to synthesis.
Okay.
Processability.
Yeah, something like that.
Okay. Good. So let's focus on. Everyone read Randon's work, or except me, or not yet? First sentences, it looks like I have read it several times. How does it look to Daniel's first sentence and Aaron's first sentence? That's fine, that's fine. cannot resist to joke right away.
Applied electrocution. It sounds like pure and applied math. Applied like second grade of quality, like pure is true. Applied is like
I also thought about using external, I guess, but I don't know.
Brandon, will we be able to accept the invitation to sit on PKM presentations on Friday 11? Or you are too busy?
This Friday?
Yeah.
Oh God. Oh, actually, I took a picture of my calendar. Hold on. I don't have to try to remember everything. I should be able to, I think.
Hey, please consider.
Yeah, because I'll already, like, the homework that I gotta get done by Friday morning will already be turned in. Oh wait, no, that's due at 5 o'clock, so that doesn't really affect it, but I got until 5 o'clock, so yeah, I should be able to do that.
Optional, but you'll be a very welcomed guest. There will be a person trained by you.
Yeah, a whole lot of training.
So let's chat about bundles. Work which was prepared in a record short time on our eyes.
I already had a template.
Still, it's very impressive. It's like a show. Like country got a talent. Prepare abstract in 10 minutes. So about pure and applied. The conference positions itself as conference of theorists.
So just saying the word applied is going to be kind of off-putting.
No, it's but very general, like impact. Even if you do not write, how you answer yourself, what is the pure theoretical impact, and what is applied industrial impact of your work if it is absolutely successful. So for industrial impact, you are crystal clear. It's like hire immediately, solve all problems, clear. But what is new theoretically or computationally? Like, and everyone who read London's work, what seems to be new? What is the like breakthrough story that everyone in theory will learn from him? You need to start thinking this way. It's not very, how to say, humble. But try to find what is new. I do see it, but
I mean, there's an electric field.
yes, not only the electric field. So
Oh shit! I should probably mention that I'm doing spin orbit coupling and hybrid functionals too.
this is good. This is good, and by the way, it's a standard thing. You may always put their composition, how many atoms, which functional, which base set. It doesn't hurt, and it will satisfy curiosity or stop anger of a reader. But you're writing that you are doing, and by the way, this only 2 lines. But if it is a theoretical conference, they will read only these 2 lines. The rest will be like, okay, industry. So you may just put it to earlier to the top, or emphasize it, or give more details, because I like how it is written, but there will be people who will need only these two lines. So there, you are telling that it will be pure electric field on one hand, and on another hand you are telling that there will be non-analytic couplings. It is not a big secret. We are working on similar problem with Yulun. Well, we means Yulun is working on. But have you did anyone observed literature for non-adiabatic coupling with electric field? So it is either everyone is so silly that doesn't do it this important thing, or there are some hidden difficulties.
Yeah, I've been stumbling face first onto those.
So right now you're getting glory just for being brave and trying to solve it. But if it will be successful, merging these two, same as Fatima did, we cannot tell 100% sure that no one else except her, but it's likely that no one tried it with enough detail to combine momentum dispersion and non-adiabatic coupling. You are candidate to be pioneer in combining electric field and non-adiabatic, and there will be some objective difficulties. The what even if you do not have first results, what do you expect? What one would expect if the system is placed in electric field? Of course, one would expect that charges will be positive charges start drifting one way, negative another. But how it will look on the language of electronic structure and eigenstates?
Your call will be disconnected.
When to change?
You know,
Would you be offsetting the field at the the interface, so there's more delocalization?
Yeah, delocalization for spatial part of the
So like a
wave
couple
function.
more with, if you do the field right?
So should be analog of Stark effect,
Right.
just splitting of energies. For some pairs of energies splitting, but for others it will be like squeezing them together. So there will be some rearrangement. And there are some objective challenges with VASP code that is not happy of combining molecular dynamics and electric field at the same time. So if it will be successful, it will be a really great thing. And you may, since there are no evidence that it will be completed, but you can express humble hope that in this direction, I really have an appetite to try and maybe resolve these objective difficulties, because it is so needed for industrial applications. Whoever can compete with me, please try. There were people who were doing it, not this problem, were trying to, like, if you're going to screen through hundreds of papers, maybe not today, but one day, non-equilibrium Green's functions. So there are people try to split your modeling cell where you put your atoms, and then put non-modeling, just assumed left and right contact, and then look for transition probability from left to the right through the model. With, like, I'm exaggeratingly simplifying it. It's through one of the quantum field theory tools, like through Green's functions. And for systems like 30 atoms, people were successful. It is even part of some codes,
okay.
like trans-siesta. But again, it is limited. It is limited way, and another thing. Why are you so humble? Charge transfer. Be brave and take current. It is ambitious. If you try to do it not as poster but as public, like oral presentation, people will start trying you with aggressive questions, because current is there is a challenge. If you were to Senegal last time and were hearing some talks, you know there is a density functional for charge density, and there is a current density functional theory, where current instead of charge density has three projections. So it's 3 times heavier, and calculations are 3 to the power 3 more heavy. But it's you wrote so much justification why it is needed for industrial applications. So any little step attempt in this direction could be useful and appreciated. Any suggestions to London's work? Or it looks good?
Just you covered my correction. So this procedure should be before
Or?
application. The method, last 2 lines.
Oh, through lines, okay.
Before application. That's all. You covered this one.
Oh, so you want method be
Before application, there
before applications.
Oh, yeah, okay.
Well, I want to give credit to Anton once again in form of a joke. If we ever, I hope we sometimes we as a group or any of you grow to the level of truly high impact journals, they abandon standard structure of papers with introduction, methods, results, conclusions. They skip methods completely. So in this sense, you are preparing for a big life without methods. Anything else? Okay, if no, many thanks for completion. So, try to implement changes. Maybe you can bounce, force and back some versions because the deadline is in how many? In 3 weeks. And if you haven't registered for Sanibel, you can observe that they have extended cheap, or how to say, discount registration for like until 10th. So if you go to the Sanibel website, you'll see that they have less until 10th than it will raise. And also, if you are looking for, if you are not sure about if you will physically go there, the payment for registration, they have pay by check, and I think they will not mandate it to be done by deadline. One can pay only when arriving and if arriving. If you like, care about spending. Okay, meeting is done. Thank you much.